All right, so let's keep cooking. Yep.
How can I find your files for PowerPoint and the recording?
If you go down to Blackboard, the link is up
Oh, I thought there is
on Slack.
Yeah.
No, it's not on Slack.
Okay.
It's on Blackboard.
Okay, gotcha.
In fact, I don't think the slides are up yet. The lectures are. I'll put the slides up right now. I'll show you on here.
You said you record your voice, yeah?
Yes. Yeah,
Is it on
they're already up there.
Blackboard, or-
Yeah, I'm going to show you in a second, actually.
Okay, thanks.
I'll show you exactly where they are. I record the voice and the screen.
Okay, thanks.
So let me just share the slide set, and I'll add that to Blackboard real quick so you have it. Yeah, so when you go into the class, over here on the left, here's the streaming lectures. So if you click on that, that's going to take you to YouTube, and here's lectures. Huh?
It's not visible.
You should be able to see it now. Yeah, it wasn't. I put it up now. And then I need to give you a link to the slides. So there's the slides. Then a couple of things I put up today that let me just talk about it while we're in here so you can kind of see where we're going. I put up a link here to this thing called GitHub we'll talk about today. And then also this thing called the self-assessment template. You should hand this in with every one of your programming assignments, starting with this assignment. So this assignment should be a relatively small one, this first one, but still turn it in. You know, I want to know how long you spent on the assignment. Based on the amount of effort you put in, what would you give yourself as a grade? Based on your final solution, what would you give yourself on a grade? Because what we're going to start seeing, especially in the programming assignments, is there's going to be a deviation between how hard you worked and what you ended up with. All right, so I need to understand your experience in going through it so I can try to give you partial credit for something that doesn't work that you worked really hard on. Does that make sense? All right, so but then specifically, those first three give me some information, but the most important one is this last one. I want you to explain to me what was your approach and what part you struggled with. So anything you can't do in code, I want you to be able to tell me in English what kind of problems you had. All right, so for every single assignment, programming assignment, not the papers, just the programming assignment, I want you to copy this, and when you go to submit your homework, paste this into the submission box. All right, and then fill it out. Doesn't have to be real long. Give me a couple of sentences, so you don't spend an hour on this or anything. This should be a 5-minute ordeal, something like that. But it gives me a little bit of something to go on when I'm trying to give partial credit. And we'll talk about GitHub today. So if you look at the homework assignment, clicked on the wrong thing. The next two assignments are up. So here's programming assignment number 2. So you're writing a Java program that goes through every number between 1 and 1,000,000 and counts the number of those that are evenly divisible by 9, 13, 27, or 81. And we'll talk about how you might do some of that today. But for submission, you should upload your code to GitHub, which we'll talk about today. And then when you submit your homework, I want you to submit a link to your code on GitHub and then paste in the self-assessment. So don't submit your code on here. I want you to submit me a link to GitHub where I can go and view your code. Make sense? And we'll talk about GitHub today so you'll know how to do that. Okay, and then there's a paper as well on the transition between the Mac OS 9 to Mac OS X and how Java played a role in there and that kind of jazz. Okay, so let's start looking at the Java language. All right, so as we pointed out hours and hours and hours ago last time, every single programming language will have facilities for remembering stuff, asking questions, and repetition. All right, so we have memory through variables. We have asking questions through conditionals. And we have repetition through loops and functions. All right, so for today, to be able to do your homework assignment, we're going to do everything up to but not including functions. All right, so we're going to introduce each of these concepts, write some sample stuff with these concepts, giving you enough stuff to work with to do the first programming assignment. All right, now having said that, I said this last time as well, but when you solve your programming assignments, remember you can only use the tools we've introduced in class. All right, so if you have had some programming in the past, you need to be careful about using stuff that maybe you're familiar with, but that we did not introduce in class. Because sometimes you'll make the homework easier than I expected it to be, and that's usually I'm asking you to do something in a certain way because I'm trying to teach a lesson. And then I'll teach you a different way of doing it next time when I introduce some new tools to you. All right? So when you're solving the problem, try to solve it using only tools we've introduced in class. So for starters, let's go ahead and I'm going to open up Eclipse here. Okay, so several of you did the homework assignment, well, hopefully all of you did the homework assignment last week where you talked about writing a hello world program, right? And there's kind of two ways you may have gone about doing this. One way is you might have done like open up Notepad or open up TextEdit. Here's the code to type in. Here's all the steps you need to do. Here's where you go to download Java, install Java. Here's where you go to compile it, taking me through all the steps. Alternatively, you could have also told me about this tool called Eclipse.org. This is something called an IDE. So Eclipse is an integrated development environment. There's several versions of this. I'm going to click download. So you'll see that there's one for Java EE developers, one for Java developers, C and C++, PHP developers, so on and so forth. The one we want to use in here is this guy right here, the Eclipse IDE for Java developers. All right, so that's what we'll be using in class. So if you want to do stuff the same way I'm doing it, use Eclipse IDE for Java. So now an IDE, integrated development environment, encompasses two pieces. On one hand, it brings in the editor, so the tool that helps us write the code. And what's nice about IDEs for Java is they do what's called command completion. So as we're writing stuff, it'll help us not make syntax errors. It'll make sure our spelling's right and that kind of stuff. It also makes it easy to test the program. So instead of having to go out and compile it and then run it like you saw me do with C earlier tonight, with Java you just hit the play button. Okay? And it's not because Java works that way, it's because Eclipse does the extra work for you in the background. If you're compiling a Java program the old-fashioned way, instead of using GCC, which you saw me use earlier for the C program, you would use Javac, the Java compiler, to compile the program. Then you use Java to run the program because you're running it on the virtual machine. All right? But we're going to introduce stuff in terms of our Eclipse IDE here. So you would download this guy. And ultimately, that's going to give you a tool that looks like this. Let me actually close all these things. So to give you a tool that looks like this, and I think when it first launches, there's like a window that comes up. I think I've done away with that. But in any case, you can go up and you can say, File, New Java Project. You can also do that from your the window that pops up by default. There's a button on there that says Create New Java Project. All right. So we're going to create a new Java project just to get the ball rolling here. And we're going to call this guy CSC535 _ spring _ 2016. All right, so we'll just create a project that we can use in here for a little bit. All right, and you can choose default location. Everything else should be fine on this. You don't need to do anything else. So we'll go ahead and hit finish, and it gives us this brand new project right here. So by default, our project looks like this. It gives us our Java runtime environment, which we don't need to worry about, but it's running in Java 1.8, which is the newest version of Java. And then it gives us a folder called source that currently has nothing in it. Okay, so we want to write our initial first hello world program in Java. So what I'm going to do is I'm going to go ahead and right click on source. We're going to click new, go to class. So I'm creating a brand new class, a brand new object. Okay, we introduced classes when we talked about the transition from C to C++. Java kept those guys. So everything in every file, at least at our high level right now, every file we work with in Java is going to be a class. Okay? So we'll create a new class, and I'm going to call this guy driver. And that'll make sense to you after a few weeks where we start moving into multiple objects in our language, in our programs that we're writing. But initially, I'm just going to call it driver because this is the program that will drive our application. Okay, and I'll go ahead and hit finish, and that's going to give us a blank file that looks like this. So public class driver, opening and closing curly braces. First thing that I don't care how you write it, but you'll see that I'm kind of a stickler about it, is I don't like this syntax when the curly brace is on the same line as the class or even functions or anything. I like to kick it down so you can see the beginning and ending where the opening and closing curly brace is. Personal preference, but you'll see me do that pretty often, and that's kind of why. So let's start off by writing our very first Java program, which is going to be hello world. So the Java program that first launches when we hit play, when we run a Java program, the object that first launches will be the one that has a main method in it. Now a little bit ago, when we were out here at the terminal, notice that I had, this is way back in the C programming language, I had a method called main, a function called main. And this guy took in an argument count as well as a collection of arguments for command line arguments. So all the way back in 1970, we had a main method. Here in Java, we also have a main method. So we have public static void main string array. You can call it args, but that part you can change. So I'm going to call this guy elephant. Okay, so arg stands for command line arguments. So this is the one guy that can change here, but the rest of this line must be identical. All right, so every Java program begins and ends with main. Every Java program begins and ends with main. So we're going to print some stuff out to the screen. So we're going to say system.out.println. Hello world. All right, so there is our first working Java program. Java is case sensitive, so this S must be capitalized. So on and so forth, and we'll talk about what some of these things mean right now. So, but for today, we're going to just do a lot of things where type it this way, and that's why it works. All right, I'll give you some of the underlying reason when we have some more time to talk about the stuff under the hood. We're just kind of getting an introduction to the language right now. So I promise you I won't just leave you hanging with just type it this way, it works. But for right now, just type it this way, it works. All right, you'll get the details next time. In more detail than you probably want, but you're going to get it anyways. All right, so this is our first working Java program. We're going to prove it works by coming up here and hitting the little play button, and there's hello world. First time you do that, it might pop up something and say, do you want to run this as a Java application or something like that? So select the little checkbox that says run as Java application, and then hit the other checkbox that says remember this. And then you'll never have to do that again. But ultimately, this is our output down here. So there's our first working Java program, hello world. We saw this in C a little bit ago, and we looked at the assembly language version of this a while ago as well. All right, so today we've learned 3 different ways to write hello world. An assembly language, which you don't like, C, which, whatever, and then the good guy. All right, the reason, I think I mentioned it last time, but the reason I like to use Java as our teaching language, I mean, it's a perfectly good modern language, and whether you learn Java or C#, they're the same, as well as Swift, it's the same. But what's nice about Java for us is because it's platform independent, it doesn't matter what kind of computers you guys have at home. So if you have a Mac, you can get Eclipse for the Mac. If you have Windows, you can get Eclipse for Windows. If you have Linux, you can get Eclipse for Linux. Same tool, it'll look the same, everything will be the same, because Eclipse is written in Java. Okay? So it allows you to do your homework at home instead of having to schlep into the lab down there. All right. So if I had my druthers, we'd probably write this, do this class in Swift or something with a iOS, but then you'd have to come to campus every time you want to work on your homework, and I don't think any of us want to do that, right? We got nice machines down there. All right. So in any case, here's a Hello World program. So let's go back here. So we're going to talk about these in passing. So initially, we're going to talk about variables. Actually, before I go into that, let's talk about GitHub first. All right, so we'll just do a basic GitHub thing. All right, so what I'm going to do here is, so we have this tool called Git. Okay, and this is, the type of application this is something called source control or source management. All right, so what Git does is it allows us to create a repository for our code, and it keeps track of all changes we've made to our code. So let's start off by doing this first, because Git has a lot to do with GitHub, but it's not the same. So we're going to learn how to make a local repository for our code so we can see all the changes we've ever made. Now, there are plugins for Eclipse that will let you do this. I do not use them. I like to teach it from the command line first. Okay, if you want to mess around with a plugin or you're familiar with one, great, but we're going to do this external to Eclipse. So what I'm going to do here, I just need to find out where this guy actually lives, first of all. Well, I'll just find it out here. So what I'm going to do is I'm going to go out to the terminal. Now, I did give you a link to the GitHub website, because ultimately we will be using GitHub. So they have tutorials on here on how to do this on Windows as well. It'll be pretty much the same, but you will have to download the Git program to do it, but you'll issue the exact same commands I'm about to do. So what I'm going to do is I'm going to move into the directory where my Java stuff lives, and I think, here, let me find it up here first, and then we'll get to it, because I store it in my Dropbox. So then CW? No, I think it's under... Ah, there we go. It's in here. Okay, so this is Dropbox. Okay. And we just called it this guy right here. All right, so basically move into the directory wherever your project you just created lives. I have it created in my Dropbox somewhere. You might put it on your desktop or something. Wherever you put it, get into the directory using the, on a PC, you'll be using the Git console. So you'll double click on the Git program and it'll open up something that looks like this. So move into that directory using the same commands I just used, and then do what I'm about to do. Now, where our code actually lives, notice we have two folders here, bin and source. Our actual code lives in that source folder. So I'm going to go into that source folder, and we see we have our driver.java here. All right. So what we want to do is we want to create a local repository for our code using the git command. So the first thing I'm going to do here is I'm going to type in git init. So you only will type this command once per repository, per project you're working on, and make sure you're sitting in the directory where your Java files are in order to do this. So if you type in ls, that should give you a directory listing. You should see your Java file sitting there. Okay? So we're going to say git init and press enter. And this initializes an empty git repository in this directory, blah, blah, blah. Now if I type ls again, nothing looks like it changed, but if I type ls-a, which shows me all the hidden files, I see I have a .git folder in here now. All right, so Git did its magic. That's all that's important. We don't need to do that ls-a thing. I'm just proving that something just happened. All right, so now what we want to do is we want to add our Java files to our Git repository. Because we've created some files, we've made some changes to them, we would like them to be added to our repository. So we're going to say git add star.java. All right, so this is going to add all of our .java files that are in this current directory to our Git repository. All we've told it to do at this point in time is we have asked Git to track these files for us. All right, so we've kind of staged them ready to be actually added to it. If I type in Git Status, we'll see the current status of the files that it's currently tracking. Notice it notices there's a brand new file called driver.java, and it says it's a new file. That means it's not currently in my repository. So when it adds it, it'll be a brand new file. So now I've made some changes to my code, and I've decided, okay, well, I actually want to commit those changes to my repository. And what's nice about Git, even though we won't use it for this purpose, is it allows us to look at old versions of our project. It also, the tool really is there for collaboration. So if we were all working on a project together, and we were all working on it independently, but committing to the same repository, and my code overwrote your code and it broke something, we could go back and either merge the two results, figure out what the correct answer is as a combination of our two steps, or roll back to one of them. We have that flexibility instead of this file being lost forever, that type of thing. So, the Git tool is really made for collaboration projects. Now, having said that, what we're going to be using it in here is we're going to be using it in conjunction with GitHub, which is a website. We'll talk about that a little more in a second, but even though GitHub also lends itself to this collaboration piece, where it's really built itself up now is a good way of distributing your software to the world. All right, so for you, you're going to be submitting your software to GitHub and sending me a link. So that is an easy way for me to look at your code, and it'll be formatted nicely where if you put stuff into Blackboard, it might look like crap. But as you get better and better and better at this, it'll also allow you to bring other people's code, fork a copy of that so you can work with that, or if you have a project that you're working on and somebody else wants to work with it, you can add them as a collaborator. GitHub lets you do a lot of different things. But for us, we're really just using it to share our projects with me or each other if you're working on a project together. I mentioned it last time, I think. I don't care if you guys collaborate some. If you submit the exact same assignment, I'm not going to be too pleased with that. So if you think your code literally looks identical to somebody else's comments and all, shoot me an email and say I worked pretty heavily with so-and-so, just wanted you to know. That way I kind of know you're being above boards about it. Okay. If I see two projects that literally are identical, same misspellings and, and stuff like that, I'm not going to be too happy. But I do want you to work with other people because I want you to learn this stuff. I'll find out on the exam if you suck at it. All right. The exam's worth enough of your grade, and since you need to get a B- or better to continue on, you have to learn this stuff. So you're only hurting yourself if you don't work in the assignment. But programming is difficult. Some of you are going to take to it pretty quickly, and you're going to feel like, oh, this isn't so bad. I mean, I'll tell you, today's assignment is pretty easy in the big scheme of things. They get a lot harder really quick. Next week's homework has 5 parts. 4 of them are pretty easy, and 1 of them is impossible. Okay? I can't solve it, so I'll try in class, but we'll see. Let's leave it as an exercise for the reader, right? So, but the punchline is that they're going to get progressively harder. Early on, the code I'm asking you to write is pretty simple because you're kind of getting used to using these tools, right? Because some of you are going to be trying to do this Git stuff, and it's going to break 5 different ways. You're not going to sure why it doesn't work this way. So we're kind of getting used to using some of this stuff. All right. So in any case, I have added this to my repository. Now I've decided I want to commit it to my repository. So I'm going to say git commit -m for my message. I'm going to just say initial commit. So I'm initializing my initial repository with my first commit of my files that exist in my project with a little message letting me know that this is my initial commit. All right, so hit enter there. It says 1 file's changed, blah, 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 tells me about all this crap. If I hit Git Status again, it says we're on branch master, nothing to commit, working directory was clean. So that means my current local directory matches identically my repository. There's no changes. Those two guys are mirrors of each other. Now, everything I just did right now all lives completely on my computer, required 0 internet connection, except to download the Git tool if you didn't already have it. If you're on a Mac, Macs already have Git on there. All right, if you're on a PC, you download Git, and it provides a little terminal window just like this. So do the same thing I did. All right, so everything we just did is about local Git repository. We have to have a local Git repository in order to push that to GitHub. So now what I'm going to do is I'm going to go over to the GitHub side of things. And I'm already logged into my account, so you can create an account on here if you want. I have a lot of repositories that I have, but bottom line is you'll come here to this thing called Create New, little plus sign. We're going to create a new repository. All right, and we're going to call this, I'm going to call this one CSC535 underscore spring underscore 2016. All right, so we'll just match it up to what we have. Once we start getting into more specific projects, we'll have a new project for each of these. But right now, I'm going to kind of use one repository for all of our intro stuff. All right, and the nice thing is, since I'm committing this stuff, I'll also be able to give you this link. So you'll be able to look at the sample code and copy it in and test it and that kind of stuff. So it gives you that as well. So I'm creating a new repository right here. Just give it a name. It's going to be public unless you want to pay GitHub money. So as long as you want it to be free, everything's public, so anybody can see your code. So if you're starting a company and you're writing proprietary software you don't want the rest of the world to see, give them their $5 a month and make it a private repository. For us, it's going to be a public repository. All right, so leave it as public, and then I'm just going to go ahead and hit Create Repository. Does it for me. All right, now what you'll notice here is it already gives you a lot of the commands. It tells you what to type when we've already done a lot of those things. So first of all, I never do this top thing, putting a README into it. I just don't do it. I skip it. It's not going to break anything, but I just don't do it. So the first thing I do is I do git init, and since I didn't do this top thing, I don't do this README thing here. Then I do, but I did do the git add my files because I already had the local file. So instead of git add readme md, I said git add star.java. Then I commit it. Okay, and now here's the important part for linking this to GitHub. So everything we did here, everything they're asking you to do here is all about the remote or the local repository, the things I just did in the last 5 minutes. These last two are the important ones of getting your local repository up to GitHub. This line right here, you only have to do one time. What you're doing is you're letting your local repository know that you want it to be kind of linked to a remote repository. Okay, so I'm going to copy that, go back out here, we'll paste it in. So git remote add, and the variable name is going to be called origin, and then there's the link to this repository, so that next thing. So now I've done that, I only ever have to do that once per project. Very last thing is this push. So what this does is I'm saying git push my local repository named master to this remote repo I just created called origin, which matches this guy right here. All right, so this will take my local repository that I already added stuff to and committed stuff to, and it will push that to GitHub. So I'll go ahead and do this. The first time you do this, it'll probably ask you for your GitHub username and password. All right, I've obviously done this on this machine before, so it has remembered my GitHub username and password, so it didn't ask me for that. The very first time you do it, you'll have to put in the same username and password you put in on the GitHub website. All right, so now it said it did it. So I should be able to go back over here to GitHub, and I can just click right here, and I'll see, here's my driver.java file. Okay, so now it lives on GitHub, and you can see the contents of my file. All right, so for you, what you would do for your homework, let's say you were done. is you would copy this link right here. And that's what you'd submit with your homework. That'll let me get to your files. Now, as an example, just kind of continuing use of GitHub, I'm going to come in here to Eclipse. I'm going to go ahead and say, you know what, we're going to be doing some stuff other than just hello world. And just for tradition's sake, we're going to call that args instead of elephant. I'll go ahead and save this. Now I've decided, okay, I'm done working for the day. Haven't done a whole lot of work, but I'm done working for the day. So I'll do a git. Make sure you're still sitting in the same directory, but we don't need to do the git init stuff. We don't need to do a lot of that stuff, but I do need to add the new files. So git add star.java. Then if I do a git status, which isn't a required command, but this will tell me what's changed, it'll tell me driver.java has been modified. My local version of it is different than the version that's currently in the repository. All right, so I'm going to say, oh, okay, well, so I'm going to go ahead and do a git commit -m, made a change to driver.java, something like that. So that's just the message you put in.
Is this one Java on your computer?
Is this who?
Page.
This is my terminal. That's that command on the Mac. Command prompt. Well, this is the terminal on Mac. If you're on a PC, command prompt will not have Git built into it. You'll have to download the Git program. Here, let me just show it to you real quick. If you're on a PC, just go to download Git for Windows. It actually started the download automatically. Okay, so you'll just download this thing, and once you open it, I won't be able to open it on a Mac, but once you open it, it will effectively give you a window that looks like this. That will accept all the same commands I'm typing in. Yeah. Okay, it's going to give you a window that looks just like this. It'll actually probably think it's a black background with white text instead. But it accepts Unix commands, which is what I'm using here. Okay?
CMD doesn't work?
Correct. CMD is like the DOS prompt on Windows, and Git is not pre-installed.
Because I installed like with Java.
Yeah, that's at the command prompt. Yeah, that's
Does
different.
it work with that one or?
It's unrelated.
Okay.
Yeah, unrelated. So Javac is the Java compiler. Git, I could use Git for Word documents if I want.
Oh.
Yeah, it's Git creates a repository of files, any kind of files. I just happen to be using it to do Java files here.
What about TextPad or Notepad++?
Any kind of file. Git is just a means of keeping track of changes made to files. They don't have to be programming files. It just happens to be kind of built for that. If you want to keep images in there, you can certainly do that, and it would compare them at the binary level. I'm not sure why that would be helpful, but you could, is the punchline. All right. So, any case, that once you've installed it on Windows just by double-clicking on it, it's going to give you a window that looks just like this. You can do the exact same Unix commands I'm typing in, all that stuff. So probably what you want to do is when you first do this, follow the part 2 of this lecture, go through the videos, and just do exactly what I do. And get yourself comfortable with that process. Make sense? Because Git's a little weird at first. All right, so when you first do it, you're going to screw up some. You're going to feel, well, why doesn't this work? A lot of times the answer is you're not sitting in the directory where your files are and you thought you were, stuff like that. All right, so that's kind of the punchline. So in any case, I made a change to my driver.java. I'm going to go ahead and I'm going to commit that change locally. And then what I can do is I can go ahead and push it to GitHub. Notice I didn't have to do the add remote thing again. I could just do that last git push command. So I'll push it to GitHub, and now it's there. So if I go into GitHub, and I hit refresh, notice it notices there's made a change to driver.java 28 seconds ago. I can click on this file, and I can look at the history of these files and notice that there's 2 versions of it. So these are things that Git and GitHub do for you. Not that important for us, But if you're looking at my various revisions to code over between multiple classes, you can see what the state of a certain file was last class, and then you can see what changes I made between last class and today, for example, if that was of interest to you. Okay? So that's kind of the punchline of Git and GitHub. They allow us to create a local backup, which is less of a big deal. And then they also allow us, Git becomes a staging tool for getting stuff up into GitHub. Now, if you noticed here, I actually use Dropbox. If you don't use Dropbox, I highly recommend you use something like Dropbox, whether it's Microsoft's tool or Google's tool. I personally like Dropbox the best. I have found some of those other ones treat certain file types weirdly, especially Google. Google has treated some files kind of strangely. Dropbox is free for up to 2 gigabytes. And actually, if you have a cuw.edu, if you sign up for Dropbox with your cuw.edu email, I think you'll get 5 or 6 gigabytes free. We entered some contest.
If only we use 360 Office, then only we get like 10 gigabytes space.
From Microsoft. That's Microsoft's solution. Yep.
Otherwise, we have just 2.
Mm-hmm. Yeah, but Concordia did some sort of contest this last year where we signed up a whole bunch of people and that got us extra gigabytes for like 2 years or something. I don't know. But in any case, I use Dropbox for a lot, so I pay for it outside of that. But it's
after 2 years, they delete the file.
no, they don't delete it. They just tell you it'll stop syncing. Give us money, but you get 2 gigabytes free forever. Is their punchline? There's a competitor I think called Box that gives you 5 gigabytes by default, but I've used Dropbox since it came out. I've always been happy with it. I've never had problems with weird files. That doesn't mean there aren't other guys that are good. That doesn't mean there aren't other guys that are better. I've just never had a real great reason to switch.
My opinion on Dropbox is it's not influenced by other company products. It's a pure online storage. I mean,
But sure, when I had my software company, I mean, I paid an arm and a leg to Dropbox for their business thing. I was probably paying them $12,000 a year for storage because I had a bunch of employees all sharing the same repository, sharing the same stuff. Now I sold all my company, so I'm on a personal account. So I think, I pay $100 a year or something like that for a terabyte. I think that's what it cost me. And then I have one for my wife's too because she doesn't want her videos and images to be in the same directory as my stuff, even though I don't use a terabyte. But so I share mine with my dad. So he uses 2 megabytes and I use like 300 gigabytes, and then we just have a whole bunch of extra storage. Okay, but in any case, I keep my Eclipse workspace in Dropbox. So whenever I make a change, it's getting backed up anyways. So bottom line is you probably don't need to use Git as well as Dropbox if you're an individual developer. Git really lends itself to collaboration between multiple developers. But you do need to use Git if you're going to push your stuff to GitHub. So this is our gateway drug to getting our stuff up to GitHub, which is an industry standard, by the way. So understanding GitHub and working with GitHub will benefit you. In the IT industry, sometimes you'll have to download a product that you're going to do a patch or something like that to a system or a third-party piece of software, and a lot of times you'll clone a repository from GitHub and install it from there. That wouldn't be like an uncommon thing. So this is certainly a standard type of thing. Okay, so any questions about Git or GitHub? It's going to be quirky until you practice it some, but you at least kind of follow the general gist of what we did. Okay. So let's start talking about variables. So I'm going to go a little bit out of order here. I'm going to introduce a lot of stuff so you see it work, and then I'm going to go back and explain the details of it, just to make sure that because we only have like 45 minutes left, and just to make sure that I've introduced everything you'll need to do the homework. Since to do the homework, you don't necessarily need to understand the backstory. Okay, so we'll introduce some stuff, and I promise you I'll give you the gory details either still tonight or next week. So we want to look at variables. Variables always look this way in Java. It's always the type followed by the variable name equals value, followed by a semicolon. Now, actually, the equals value part is optional. You don't have to define a variable and give it a value at the beginning. But eventually it has to have a value before you can use it. So I'll show you both versions of that here. But this is the generic form of a variable. So we're going to go ahead and we're going to create a variable named A. We'll set it equal to 5. I'll create another variable named B, and then the next line set B equal to 7. All right, so there's an example. So I have two variables here, A and B. This first line, A has a type of int, its name is A, and it's equal to the value 5. In this case, B, its variable type is int, for integer, it's built to hold integers, but I did not give it a variable when I defined it. Instead, I gave it a variable later on right here. I set B equal to 7. But notice I did not put an int in front of it again. I had already defined it. This is the definition of the variable. This is me giving it a value. This is kind of a shortcut. This is defining it and giving it a value all in one line. Make sense? All right, so for starters, just to kind of get the ball rolling, the variables we're going to be introduced to initially are going to be the primitive types. So this is byte, short, int, long, float, double, boolean, and I missed one in here. Let me throw char right after long here, and char. Okay, those are our primitive types. I'm actually going to spend quite a bit of time next time talking about the differences between a bunch of these because a lot of them are very similar. All right, but for us today, we care about ints. And, well, actually, let's see, the homework just needs to be even divisible stuff. So actually, our entire world is about integers right now. Okay? So we only know how to deal with whole numbers. Positive and negative whole numbers, that's our integers. Okay? So we're only going to use those today as our examples. All right, so I have two integers here, one named A, one named B. They both have values. I'll go ahead and print out A, system.out.println A, and I'll print out B, system.out.println B. We'll go ahead and run the program, so we should get the value of A is 5, the value of B is 7. Okay, so what happens here is when I run this, A is a placeholder. So variables are placeholders. This guy is ultimately going to get resolved to the value in which it holds. So A, because it's a variable, will resolve to the value that it holds, which is 5. So at runtime, this guy will turn into a 5. Similarly, B will resolve to its value, which will boil down to a 7. It will resolve to the 7. So I'll go ahead and run this. We should get the 5 and the 7. All right. Now, what if I defined B, but I forgot to give it an initial value? Notice here that Eclipse is screaming at me. It's saying that this guy may not have been initialized. So if I hover over that B there, it says the local variable B may not have been initialized. Not happy about that. It suggests the fix. It actually will do the fix for me. So it'll go ahead and do the initialization for me if I want. Okay, but what I had here is I initialized it myself. I just chose not to do it on the same line I defined it. Probably not very common in our world right now. When we start dealing with loops and things like that, there are situations where we might initialize the variable separate from where we defined it. But for right now, you will pretty much always define variables like this. Okay? So that's defining variables. Two separate variables, A and B. Now let's talk about some operators. Arithmetic operators. Plus, minus, times, divide. Exhilarating. Exhilarating stuff. We're all familiar with all of these. So if I print out A, well here, let's just do another variable. Say int C is equal to A plus B. and then I print out C here. C is equal to whatever A resolves to, which is 5, plus whatever B resolves to, which is 7. So C is going to equal 12. I'll go ahead and print out C. So this should print out a 12. Make sense? Okay. Now, what would happen if I said B is equal to 4? Does that change the value of C? Ah, so our first experience with side effect.
No, because the expression before.
Okay. But certainly this is an example of side effect, right? We have to ask the question, did what we did here, was it impacted by us changing B here? Now, over the last few minutes, I keep using this phrase, I keep using this word resolve. When A gets resolved, it actually boils down to its actual literal value. So it's as if I said 5 here. It's as if I said 7 here. So in reality, A and B are not even involved in the creation of C. The values that they resolve to are, but not those variables themselves. Make sense? Okay. So this will not have an impact on this, except B will be changed. From this point forward, B is now 4 instead of 7. But B was 7 when I used it right here. All right, so this is still going to be a 12.
So on that note, after that B equals 4, if we put another line, another integer, nope, after.
I'm going to end up doing that anyways.
Oh,
What?
well, yeah, so if you said, you made another integer of like C equals A plus B after that.
If I say C equals A plus B again, did that same thing?
Yes.
Yeah, now it's the new version of B. Yep. What if it what?
I want to just, if you don't mind playing command, yes, C equal A plus B.
Like that?
Yep.
All right, and then you want me to print out C?
Yep.
All right, here, so I'll cut these guys out of here so they don't get in the way. This comments that line out. 2 front slashes says ignore this line. All right, so I initially made C equal to A plus B, which would be 12. Then I changed B to 4. Then I changed C to be A plus B, which should be 9. So what's going to print out here, a 9 or a 12? The 9 will print out here.
So if you don't take out the first command, how does it work?
This guy?
Yeah.
If I remove that? Okay, well, if I remove that, then this line's going to be an error because it doesn't know about C. I haven't defined C. I'm trying to give a value to a variable that hasn't been defined. So I would have to put an int in front of that. C has to be defined once to use it. So once it's defined, we don't have to define it again within that same scope. Don't worry about that word right now. We'll talk about it. But right now, our whole world's in one scope, so it doesn't matter. Okay? But before we can use a variable, we have to define the variable. So if you're not going to define C up here, you have to define it down here. But notice if I have it defined here, we're not allowed to define it down here. It's already defined. So it's screaming at us saying a variable, a duplicate local variable C. You've already defined this guy. Why are you defining another variable with the same name? Okay, so I would just take the int off of that.
So, but it doesn't give you an error about defining B twice?
I didn't define B twice.
1 is 7.
I defined B right here. That's defining the container. I went to Target and I bought a container. I bought a Tupperware container. Okay. Then I put a meatball in it. Then I changed my mind and I shoved a piece of pizza in there. Same container. Make sense?
Yep, got it.
Okay. All right. So that's our math stuff. And so let's go back here a little bit. So we have A is 5, B is okay. So let's
If
do.
you keep both of like the first one system.out.print B, like you will not keep slashes in it, then what will
All right, so let's get rid of the second C just to show you what I was trying to do here before. So now we start off A is 5, B is 7, C is equal to A plus B, which is 12. We'll go ahead and print out B. B is 7, so print out 7. Then I'm changing the value of B to 4. So when I print out B again, it'll be 4 because I've altered it. Okay, no longer is there a meatball in there. Now it's pizza. So if I'm going to eat out of that Tupperware container, I'm going to find pizza in there, not a meatball. Probably because I already ate the meatball.
I mean, there will not be two printouts like.
There will be. This is going to print. This will print out 7 first,
Yeah.
and then we'll see a second printout for 4. So every single time we do a system.out.println, something prints out. Yep. So we're going to see 2 things here, 7 and 4.
But you cannot put C equal A plus B without int after B equal 4.
You can't do it after B equal 4? Yeah, I can. I can say C is equal to A plus B right there. That's fine because C is already defined. So since it's already defined, I already bought that Tupperware from Target. I have it.
So
I'm just putting something else in there. Make sense? Yeah, so every piece of Tupperware we want to store crap in, we have to define once.
now it counts with new B.
Yeah, not right. Now it'll be the new version of B. So A plus B will be the 5 plus 4.
So to kind of display that, I mean, if you wanted to, you could say under that system, that first system out print line,
C
print and B, just copy it. Yeah, and you'd have a B and C.
Yeah, so you wanted to see both of those?
Yeah.
See it twice?
Yeah. So
Okay, so B the first time will be 7, C is 12. Then B changes to 4, C changes to 9. So now it'll be 4 and 9. Okay, so 7, 12, 4, 9.
Got it? Yep. Thank
All right? But I really think this Tupperware example makes the most sense, right? Okay. Well, I mean, the thing is that it's so easy for us to try to disconnect this from real life, and it's not. I went to Target, I bought a container to put crap in. Okay, the only kinds of stuff I know how to hold right now are integers. That's the limitation I put on us right now because your homework only requires you to understand integers. All right, so this container can only hold integers. So I'm going to put an integer in there. Now the next time I try to look in this container, I'm going to find the last thing I put in there. If I put something else in the container, it's going to overwrite the thing that was in there, and now the next time I look in there, it's the new thing. Okay, but if I have a container, I don't. The thing is, I'm weird this way. I name my containers. So when I go to Target, I buy Tupperware containers, I name them. It's a weird pet thing. It's kind of weird, I guess. So I'm trying to connect it. So I write on it with a little Sharpie. This container's name is C. This container's name is A. This container's name is B. So if I already have a container named C, I can't go out to Target and buy another one and name him C. The old C will get jealous. Right? Can't do that. We need another container. We'll name him D. So we're going to keep building containers. They have to have unique names. Okay, that makes sense? All right. So now let's talk about these math operators. So plus, minus, times, these guys are all going to act exactly like you'd expect them to act. Okay? It's the division one we need to be careful about. And it's also very related to our homework assignment. All right, I'm going to show this to you. Just for the sake of sanity here, let's just get those all in one line. If that's cool with you. So now I'm going to say int C is equal to B divided by A. And then I'll do a system.out.println C. What's this going to output? So B is 7, A is 5. What's 7 divided by 5?
1.2.
Yeah, so it's 1. Okay, so we see it's 1, right? Okay, I've just proved it, nothing up my sleeves, and printed a 1. So let's talk about what this meant. So we have this idea called integer division. So remember way back when you were a lot younger, you had I had it in 3rd grade. I had long division. Remember long division? So long division. If we took 7 divided by 5, what did we have? We had so 7 divided by 5 would equal 1 remainder 2, right? So the integer division aspect of this is the 1. That's the answer we just got, the 1. Okay, the whole number part of this. The remainder 2 here is 2/5. That's what that's the fraction part of it, right? Okay, but this, what if we want to get the remainder part of this? So if we go back here to our arithmetic operators, I'm going to throw one more guy here. The mod operator. This is modulus, modulo, modulus, whatever. Pick your poison. Okay. The slash gives us the integer, gives us the quotient of an integer division. Modulus gives us the remainder of that same division. So let me show that to you. So I said C is equal to B divided by A. Its D is equal to B mod A. I'll go ahead and print out D. Now we just did the math over here, right? We saw that 7 divided by 5 is 1 remainder 2. C should be the 1. D will be the 2, the remainder. Make sense? So there's our 1 and our 2. All right, so those are going to be very handy for your homework, by the way. Now there's some interesting things with modulus. A couple things we want to understand that are pretty important that I don't want to skip right now. Who would have thought that long division was going to be this important in our computer science and IT career? Something we learned in 3rd grade actually turns out to be incredibly important in our most advanced security algorithms, to be honest. So this idea of modulus is a huge, huge deal. So if I say any positive number when divided by a positive number n will have a remainder in what range? So if I ask the question, if I take any positive number and I divide it by any other positive number, what will the possible range of values be for the remainder? If that positive number is n. So for instance, if I took a positive number and I divided it by 5, what are the possible remainders I can have when dividing something by 5? 0 to 4. Okay, what if I divided something by 9? 0 to 8. So 0 to n minus 1. 0 to n minus 1 is the range of values that you would get when you divide any positive number by a positive number n and look at the remainder. Make sense? You'll never get an n because that means that you did the division wrong. It went in an extra time. All right, so we can't, if we say, for example, if I have 8 divided by 4, the answer to that is 2 remainder 0. Okay, not 1 remainder 4. That doesn't work, right? Technically it's accurate, but that's not how we would say it, right? You don't have, 4 goes into 8 one time with an extra 4 left over. means it went in again, right? All right, so it's always going to be n minus 1. And that's pretty important for solving a lot of different problems. We're not going to have the luxury of seeing one of those problems yet. But it's important to mention that to you because understanding this idea of long division, when I divide an integer by another integer, I will always get a whole number because it's integer division. Both sides of it were integers. Therefore, I will get an integer as a result. Now, if one of the sides was a non-integer, like a double or a float, which we don't know yet, I've introduced the words, but we haven't messed with them yet, then I would get a bigger number. So for example, if I said b divided by 5.0, for example, this guy's going to boil down to a floating point number, but I can't fit that inside of an integer. Okay? So it's going to tell me this guy is, I need to cast it to an inch. Type mismatch cannot convert double to an int. All right, we'll mess with that more later, but for right now, we're going to say we're pretty good here. Now, having said that, what if I said, let's do 7, let's say 4. So 4 goes into 7 once with the remainder 3, right? All right, so it more than halfway goes in again, right? So if I take 7 divided by 4, the floating point answer is 1.75. So the question is, what's it going to print out? Is it going to print out a 1 or is it going to print out a 2? Is it going to round it? It's definitely going to give us a whole number because we're dealing with integers. What do you think?
I think one print out a 1.
Okay, so if I take 7 and I divide it by a 4, you think and store the answer in C, you think this is going to be a 1.
Yeah, because 4 goes into 7 once.
It is one that
Okay, and you think that this guy will be the remainder 3.
Yes.
That's pretty clear, okay? So there's our 1, there's our 3. Well, why didn't it take 1.75 up to 2? Isn't that what humans do? Don't we round up? Anything above 0.5 goes up? It's what we would usually do, right, as human beings. So what happened here? I mean, yeah, you're right. You said it from the human perspective that, oh yeah, it only goes in there once, so it's 1. Okay, but there's something physically happening under the hood here. Integers do not know how to hold decimal point numbers. They don't try to do anything. They're not capable of holding them. So we do what's called truncating. So if you try to shove a decimal point number into an integer, the value is truncated. That is, cuts off decimal places. No rounding. Integers are incapable of holding those decimal places. Therefore, it effectively ignores them. So it truncates. All right? 1.99999 is a 1 when thrown into an integer. Okay? So that's us working with integers, doing our little math trick stuff. Plus, minus, times, divide, and modulus. The only ones we really need to be concerned about a little bit is that divide and modulus when we're working with integers. Kind of plays by the long division rules, not decimal points. Okay? And so we'll leave it at that for right now. Now, let's talk about conditionals. So in order to talk about conditionals, we have to first talk about Boolean expressions. So we can't ask a question if we're not able to interpret the result. Okay, so if I'm walking down the hall and I say, am I about to fall over? My answer is going to be yes or no, true or false. Right? We have to have a way of representing an answer before we can ask the question and respond to it. Okay? So a Boolean expression is any expression that boils down to a single value of true or false. Okay? Any expression that boils down to a single value of true or false. Now what's important about this is, and kind of we've already been practicing this a little bit tonight, I've been talking about this idea of resolving variables. So when we see the variable name A, we want to resolve it to its current value. B, we want to resolve it to its current value. Now, when we look at a Boolean expression, initially we're going to be looking at simple ones. But some Boolean expressions can look very, very, very complicated. But ultimately, they still just boil down to a single value of true or false. This is no different than if we're in real life and we're saying, well, if it's sunny outside, or the rain isn't starting for an hour, or the movie starts later than we thought, or at the end of the day, we're going to finally have a final answer of whether we're going to go and do something or not, and that's going to be a single true or false. Okay, if any of those things are true, we're going to do this. All right, so we can have Boolean expressions that look very complex, but at the end of the day, they still boil down to a single value of true or false. Early on here, we're going to be dealing with very simple ones, so we don't have to worry about that too much. So, in order to leverage Boolean expressions, we have to have Boolean operators. So our Boolean operators, we have a couple of different kinds of Boolean operators. We have our arithmetic Boolean operators. So we're all familiar with these, or at least most of these. So we have less than or equal to, greater than or equal to, equal to. By the way, there's no spaces between these. Double equal sign, no spaces. That's the equivalence operator. Not to be confused with the single equal sign, which is the assignment operator. Single equal sign assigns the value on the right to the variable on the left. That's what the single equal sign does. Double equal sign tests for equivalence and boils down to true or false. All right, we'll see these as an example here in a minute. Then we have not equal to. Okay, so these are our arithmetic Boolean operators. So if I say A less than B, A is 4, B is 7. Is it true that A is less than B? Yep, so this is going to print out true. There's our true. If I say A greater than B, 4 is not greater than B, I'm going to get a false. A not equal to B. Is it true that 4 and 7 are different values? It's true. It is true that 4 is not the same number as 7. There's my true. A equal to B. False. 4, 7, different numbers. We'll make them both 7. A less than B. False. 7 is not less than 7. So this is false. What about if I said less than or equal to? Now it's true. 7 is less than or equal to 7. All right. Make good sense? Pretty much follow those things? All right, so those are our arithmetic Boolean operators. Now we have our logical Boolean operators. This is double ampersand, double vertical bar. This is and. This is or. Okay, we actually have a couple of other ones that we'll talk about. We have bitwise ones. I'm not going to talk about them today. That's just going to confuse stuff. But in our little world right now, these are the only guys that exist. Okay, for logical operators. So now I can say something like this. Good. XORs exist, but so yes, they exist, but not in our world yet. we don't know about them yet. Okay, so in any case, let's do this. So I'm going to say if A is less than, well, here, let's do this. Change it back to a 4. A equal B, or A is less than B. So is A equivalent to B? No, that's false. So that'll be false on that side. So this will resolve to false. Or is A less than B? Is 4 less than 7? That's true. So this will resolve to true. So now I effectively have the Boolean expression false or true. And an or is true as long as at least one of the sides is true. Okay, in this case, exactly one of the sides is true. So this whole thing will boil down to true. Now, if on the other hand, I said A is greater than B here, so now we have a false or false. Both sides are false. That's the only way for an or to be false. So this will boil down to false. Make sense? Put an and there. A is equal to B, and A is less than B. Actually, it's kind of nonsensical, so let's do it this way. A is less than C. So C in this case is going to be 4 divided by 7. No, 7 divided by 4, which is 1. So this is going to be a 1. So is 4 and 7, are they the same number? No. Is 4 less than 1? No. So this is false and false, which will be false. Turn this around. Is 1 less than 4? Yep. Is 4 the same as 7? Nope. False and true is false. Okay, so this is going to be false. So the only way an and is going to be true is if both sides are true. Make sense? All right, so those are our logical operators. We also have a, I'll throw one more in here. We have the not operator. So what a not does is it just flips. Not true is false. Not false is true. Flips the Boolean. So for instance, we just saw a false here. If I take that entire, I'll just put parentheses around all the stuff that we just did that turned out to false, and I put a not in front of that, that'll flip the false to a true. So we did the same Boolean operator, or the same Boolean expression inside. It boiled down to false, and then I flipped it to true. All right, make sense? All right, so those are our various Boolean operators, which then leads us into writing conditionals. So conditionals in Java, we're going to look at an if statement. The syntax for an if statement is the word if, lowercase, opening parenthesis, Boolean expression. We already said that a Boolean expression is any expression that boils down to a single value of true or false. So we just saw several of those, right? Wrote a whole bunch of stuff, and every single one of them printed out a single value of true or false here, no matter how complex it started looking. Okay? So an if is the word if, open parenthesis, a Boolean expression, closing parenthesis, opening curly brace, let's say 0 or more statements, closing curly brace. We'll talk next time that technically these curly braces aren't absolutely required, but they're never, ever, 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 ever wrong. So you should always put them there. It's good programming practice. But for right now, just assume they are required for right now. So 0 more statements, so let's go ahead and write an if. If A is less than B, system.out.println, A is less than B. All right, so A is 4, B is 7. Is 4 less than 7? Yes, so since this is true, we will get inside of this if statement and print out A is less than B. So there's my output. Now, if I changed A to 8, my program will not output anything because I'll ask the question, is 8 less than 7? It's not. So we'll skip past the end of the if and keep moving on. We won't execute what's in there. So this is this line conditionally happens. All right, so there's the output of that program. Now I can have an else. So now, in this case, is 8 less than 7? No, it's not. So we'll drop down to the else and we'll say A is not less than B. Otherwise, if it was, we'd say A is less than B. So there's the A is not less than B. We change this guy back to a 4. Now it's A is less than B. All right, so this allows us to ask questions. If this is true, do this. Optionally, we can have an else where we would read that as otherwise do this. Make sense? All right, and we can actually string these guys together. So we can say if A is less than B, do this. Otherwise, and I'm actually going to write this in a way that I would not actually write it usually. But because you have to solve this problem in terms of the way that only the things I've shown you, we're saying that these curly braces are always required. In our world right now, curly braces are 100% required. Okay? So I'm going to ask a follow-up question. If B is, let's see, I'll give you enough to bite on. I want to ask the question if B is odd, if it's an odd number. How would I ask the question, is B an odd number? Odd numbers like 1, 3, 5, 7, so on and so forth. Remainder of 0. Okay, so it's the B mod 2. So if I take the current value of B, I divide it by 2, if it has a remainder of 1, or we could say if it's not equal to 0, if 2 did not evenly go into B, then this guy's odd. Make sense? Those are synonyms to each other. Not equal to 0 or equal to 1, because anything mod 2 will have a possible result of 0 or 1. Right? 0 to n minus 1, and 2 if n is 2. All right? So if this guy is odd, we'll do system.out.println B is odd. Else system.out B is even. Okay, now one thing that you'll find handy, by the way, is at least early on, and actually for you guys throughout the entire course, type as many things as you possibly can. Try to limit the amount of stuff you copy and paste. It's going to be beneficial for you to type the same stuff out over and over and over again, so you start seeing the patterns of what mistakes you make. When do you forget these little semicolons at the end of the line? Because if you forget one of those, it yells at you. Okay, so you want to get into that habit of system.out.println with a capital S. Semicolon at the end of the line. That's how you move on to the next line. So get into that habit. This is a practice. Remember, this is like a sport. Okay, so even though you academically understand all the stuff I'm doing here, when you actually go to do this for your homework assignment, especially those of you who haven't programmed before, as easy as this homework assignment actually is, it's going to be challenging. Okay, because you're going to have this disconnect in your mind. You're going to say, well, I understand what it's asking. I know how I want to solve this as a person, but how the heck do I write to Java to do that? And what's going to be, you're going to be getting your own way. Because we're so good at solving problems, we have trouble articulating the solution. So the thing you're going to have to drill yourself on for next week is slowing it down and asking all those little tiny individual steps to solve the problem. Okay? Super easy problem. Would only take 30 seconds to write the answer. But most of you are going to spend substantially longer than 30 seconds on it. All right? So just expect that going in. That doesn't mean you suck. It doesn't mean you're stupid. It means that you're a beginning programmer. Okay? So, now we're asking kind of a more complex question. If A is less than B, print out A is less than B. Otherwise, if B is odd, we'll print out B is odd. Otherwise, we'll print out it's even. All right, so right now, is A less than B? Is 4 less than 7? It is. So this guy's just going to print out A is less than B. We will never get inside this else. So we won't even ask those other questions, right? Because it's always an either or. When we have an if with a corresponding else, you can never get into both. It's always one or the other. If this is true, do this. Otherwise, do this. All right, so this is going to print out A is less than B. But now if I go ahead and make A an 8, is 8 less than 7? It's not. So we'll drop into this else. Now, we'll take 7 mod 2. Is that not equal to 0? It's not, because it's odd. So we'll print out B is odd. There's my B is odd. Now, if I change B to 8, is 8 less than 8? It's not, so we'll fall to the else. Is 8 odd? It's not, so we'll fall to this else. We'll print out B as even. Make sense? Okay, so that's introducing this idea of conditionals. All right, now the next thing I'm going to do is we're going to learn about loops. We're going to write one loop that takes us through a bunch of numbers. All right, and what I'm going to do here is we're going to change up this logic a little bit. Well, let's just gut this. Just gut all this. Ooh, you didn't learn this yet. Pretend like you didn't see that. All right, so this is something called a for loop. All right, so this is how we do repetition. This is one of several loop types that we have for doing repetition. This is the one you'll need for your homework assignment. Okay, we'll talk about the differences between them next time when I'm filling in some of the gaps. Right now, I want to limit the amount of trouble you can get into. So the way a for loop works, it always starts with the word for, all lowercase, followed by an opening parenthesis. And then this is our value we are counting, using to count. Okay, so for loops lend themselves to counting problems, and we'll rehash that next week. But we're using a for loop in this case to count between the numbers 0 and 9. Okay, so we're starting a variable I off at 0. So we're defining a variable capable of holding an integer named I. We're starting them off at 0. This piece happens exactly one time for the entire for loop. So this is like a setup for the loop. Then we ask the question, is the current value of I less than 10? Is 0 less than 10? Yes, it is. So think of that like a conditional. We just asked the question. Therefore, since that was true, go ahead and do whatever's in the body of this. So we'll print out the current value of I, which is 0. Then we spin back up here. We're modifying the value of I. So I is now equal to whatever it used to be equal to plus 1. So that 0 just became a 1. But now, since this is a loop instead of a conditional, we're going to ask this question again. Is 1 less than 10? Yes. Print out 1. 1 becomes 2. Is 2 less than 10? Yep. So on and so forth. Is 9 less than 10? Yes. Print out 9. 9 becomes 10. Is 10 less than 10? No. So we fall past the end of this. We'll print out done. So this should print out 0 through 9 and then done. And with a little tweak, now it'll print out 0 to 999 and then done. So right off the bat, we see the power of loops, right? So we can now apply stuff to lots and lots of problems. So that's 0 to 999 and then done. So now what I can do is I can choose to, instead of just printing out the value of I can choose to use that value to do something. So maybe I'm going to ask the question, if I mod 2 is equal to 0, system.out.println, I is even. Else, system.out.println, I is odd. So now, instead of just printing out the value of I, I'm going to determine if it's an even number or an odd number. Okay? And actually for this, in this case, since it relates to your homework, I'm going to actually start this off at 1 and go all the way up to 1,000. All right, so Boolean expression just like anything else. So I starts off as 1. Is 1 less than or equal to 1,000? It is. Is 1 mod 2 equal to 0? Nope. Print out it's odd. 1 becomes 2. Is 2 less than or equal to 1,000? Yes. Is 2 mod 2 equal to 0? Yep. Print out it's even. So on and so forth. So we should just see it bounce back and forth, right? So we'll go ahead and run this. So there's our even, odd, even, odd, even, odd. So we applied that logic all the way through. Make sense? All right, so for your homework assignment, you're going to be going through a collection of numbers in a range. So in the assignment, I tell you to go from one number to another number. Here, let's just look at it here. 1 to a million. Oh, that's not this class. Too many classes. So you're going to write a Java program that counts the number of numbers between 1 and 1 million that are evenly divisible by 9 or 13 or 27 or 81. So you want to count the number of numbers that are evenly divisible by any of those. We're not printing those numbers. We are counting how many of them there are. That make sense? So for instance, if I told you to tell me how many odd numbers are there between 1 and 1,000, it should be 500, right? Half of them are odd. All right, so your answer there would be 500 related to this. I want you to count how many values you run into between 1 and a million that meets that criteria. That is, they are evenly divisible by any one of those 4 numbers, potentially all of them, but at least one of those 4 numbers. Make sense what I'm asking? So your final answer, which should ultimately print out to the screen, is one number. The total count of numbers that you found that are evenly divisible by at least one of those. Make sense? No, I've told you how to do addition. Aren't we just adding 1 to I every single time here? So couldn't we say something like int count is equal to 0, and every single time we find an even number, we can say count is equal to count plus 1. And then here at the end, we can just print out count. So every single time we bump into an even number, we'll go ahead and print out count. And there's our 500. We found 500 of those guys. Make sense? All right, questions, comments, concerns, bribes. All right, so here, one last thing just at the very end. I'll go ahead and commit those changes. Oh, I need to add the Java. I'll commit the changes, and then I'll go ahead and push my current code up to GitHub. So here it is on GitHub now. That's not it on GitHub. Is this it on GitHub? This is it on GitHub. So there's the current version of the code. I'll go ahead, I'll just paste this into the homework assignment so you'll have kind of my example of code you can work with. Make sense? So you have that. Is that here? Where are we at? It's this guy. Oh, hold on, I gotta do. Oh, my edit mode's off. That's the problem. Sample code from class. All right, I will see everybody next week. Same time, same station. Unless you want to go another hour, maybe?